Hey everybody, welcome back to the Build Show. Steve Basic here. I'm on site down at our Hilltop Arrow House, and we're going to talk about general water management today. So I have the Hilltop Arrow House behind me. You can see it's a beautiful green box, right? Zip would love to hear me say that. But the reality is this is what I call the Alamo situation, right? The weather-resistant barrier of the zip sheathing is the Alamo. That's the last place that I'm battling water. Remember, water is the #1 killer of buildings, right? So we know on top of the weather-resistant barrier, or the green zip R sheathing that we have here, we're going to put a rain screen, we're going to put siding, we're going to paint the siding on the outside of that. But keep in mind, in my mind, as an architect and building scientist, the siding is the sacrificial layer, right? That's the layer that the sun sees, that the rain, ice, snow, all of the environmental conditions that challenge our houses, the siding takes on that battle. And water is inevitably going to get behind the siding. I know there's a lot of people out there that are going to say, oh, I caulk it really well and I seal it up. To believe that the siding is a face sealed system and a water barrier is about as naive in building as you get in myths and stories, right? Water's getting behind it. So how do I deal with that water? I put a rain screen on there. What does the rain screen do? Well, it provides drainage, but it also provides ventilation. And on the back side of that rain screen is the Alamo, right? When I look at this house, I see a house that's fully sheathed. I see the windows installed. I see all the joints taped, the windows flashed. The windows from a water management perspective. In my eyes, water management is taken care of here, right? I should be able to take a hose down the house right as it is, and it should be successful. Everything that I do from this point on is in assistance to the war that the weather-resistant barrier is fighting. Let's jump back to the studio. I'll break out a simple wall section. We're going to talk a little bit more about rain screens and siding and the Alamo and how we put buildings together to battle water. I'll see you back at the studio. Hey, everybody. So hopefully you enjoyed that little trip out to the job site there, Hilltop Arrow, being built by Arrow Building, owned by Jake Bruton, good friend of mine. He's doing a beautiful job out there. Always like working with Jake. He's a really good collaborator and teammate. So we have a lot of fun together, which makes it even more important. Speaking of fun, collaboration, guess who's here? Big Red. We're going to dive into detail, and we're just going to talk about some basic water management concepts. But before we dive into the details, you know, I can't stress enough. I've been in this business almost 30 years in the building industry. And as much as you tell everybody water is the #1 killer of buildings, next year there will be literally thousands of buildings dying a slow death due to bad water management. So it's something we can never talk enough about and strive to get a better understanding of. So anyways, #1 killer of buildings. Let's talk about it. Let's talk about the basics. Let's get some fundamentals down, out of the way, and some thoughts. Beautiful green box out there. So let's have at it. Let's grab Big Red. Let's take a look at these details. All right. So grabbed one of the details here. It's a band joist detail, wall section detail from the set of drawings. You can see there's the bottom plate of the second floor. Give you a little orientation. And the double top plate of the first floor here. Band joist here. And this is our floor truss in there with another floor truss there. And our gypsum board ceiling here, and then this is our floor sheathing up there, so you get a sense of what's happening there. So that's our floor assembly, and then for the wall assembly, you can see we have our T-stud. So that's the short cord, long cord, Another gypsum board there, and then the dowels that make up that T-stud here. Let's see those dowels in there. Wide cord, and then a gypsum board there. And you saw there we had the green zip board on there as our weather-resistant barrier, and that's basically right there. And then we have a layer of insulation in there, so we're using the R9 zip panel here. And then, like I said, this is the T-stud frame. But what we're really talking about is what happens when water challenges this siding. How do we prevent it? Now, typically, a lot of builders you'll see, they put up their plywood or OSB, they put up their weather-resistant barrier, which could be a roll-out paper membrane. In this case, it's zip, all taped up. And then they apply the siding to that. But in the case here, we actually have a space here, and that space is roughly 3/8 of an inch, and it's created by a product by Benjamin Obdyke. They make these plastic furring strips that you can use either vertically or horizontally that provide a space behind our siding and the weather-resistant barrier there. And that space actually has 2 points of interest. The first one is it's a drain, right? It allows water to migrate down due to gravity. But 2, it has the ability to dry. So while the water is falling, you have air going up that channel and helping to dry out the backside of the siding, and if any moisture migrates into that zip board, they both have the ability to dry out. So you basically have a channel with your siding here and your zip sheathing there, but they both have the ability to dry out, and water has the ability to drain out. So I call it down and out for the drain, and for the dry, it's up and away. So both are mechanisms to get rid of moisture. Obviously, the drain is to get rid of bulk moisture, or basically water, and the dry is to get rid of, moisture vapor, right? The drying potential of the wall. Now, as I said in the video, I know there's a lot of people out there that sit there and say, oh, we caulk and we make sure we seal up our siding and we don't get any water through there. Well, like I said in the video, I'm from the idea that that's about as naive thinking as you get. Water is getting behind the siding. It is going to get there, no doubt, and it's going to get behind the siding. Now, one of the issues I have with sealing up the siding is beyond the fact of the naive nature of that thinking is, I always tell people, when you're trying to seal something out, you should really be aware of what are you sealing in should be the question you're asking. And, for those that have seen a bunch of my videos, you know that I'm really keen on what questions should I really be asking. So it's not really about sealing water out, because if I do some excellent job and I seal up all these joints and I basically create this water barrier myth that I think is happening, well, the instance water does get into that system, then it tries to dry out, but it can't, right? Because I've done such a good job trying to keep water out of the system. Once it gets in, the water can't get out. So there's a reason why we call this water, you're going to love this, pay attention, water management. I know it's always a treat to have to spell while on video, but, right? It's not called water barrier. It's not called water dam. It's not called water stop. It's called water management. And why do we call it water management? because we're managing the water. We have to give it a place to go, drain, and a place to dry out should things get wet behind our system. There is no such thing as a water barrier, right? It does not exist in a wall assembly. Now, you can think you create it, and it might even make it 1 year, 2 years, 3 years, 4 years, 5 years. But in a 50 or 100-year life cycle of this house, it is not going to make it. Mother Nature will win that battle. We need to concentrate on management. So, how do we do that? Well, we have the siding, and I colored over this pretty much. Actually, I have a second one here. Let's do this. We'll throw this right over the top. We'll have a second one here. So, we have our siding. Notice the siding has a nice little lap joint. So as water hits that, it drips into the next one. There's a little cove here, kicks it out, drips, kicks it out. So the siding is what I call the sacrificial layer, right? That's the one that takes the water, it takes the ice, the snow. It's the one that takes the sun, the sunshine, the UV, all of it. It's the sacrificial layer. It's what we put out there to basically take the beating. Now, when I was out on the job site, I called the face of the zip here, I called that the Alamo. And the reason I called it the Alamo is because that is the last stand before water becomes a problem for me. But even though I consider it the last stand and I'm calling it the Alamo, I want to get rid of as much water before it gets to that face as I possibly can. So I put the siding out there. I put that 3/8 inch Benjamin Obdyke spacer in there so that we get our drain and our drying potential that we talked about before. But so when it rains, we get the bulk of the water. It just runs down the wall and drips off. Whatever makes it through the siding, which it will, comes down through that little drainage space and drips out through the bottom. So nothing is ever really challenging the face of that zip sheathing. And again, we use the R9 sheathing. Notice that I call for all the joints to be cleaned, taped, and then roll all the joints typical, right? It's very important that when companies like Huber develop products and they say, hey, you know, the surface has to be clean, and when you put the tape on there, the joints need to be rolled, that we do that because that's how the system was designed. But that Alamo thinking, another way to think of it is that I have the face of that R9 sheathing here. I have the airspace here, which we'll just call A. And then I have the siding here, right? So it's actually acting like what some people would consider a two-stage joint, right? Because what do I need to get water to move through a system? Well, I need three things. I need one, I need the water. Two, I need a hole. And three, I need a force. Right? And in this case, it could be wind, it could be capillarity, it could be a whole bunch of things that are getting in there. But before I get to the force, let's try and eliminate the holes. And we do that by taping the joints. Now, I don't deal with the field nails on the zip sheathing. We've tested them on a number of projects. We can't push air across them, so I'm very confident that we're not going to get water in those holes. I mean, it might take on a drop or two here or there, but I don't think ever that they're going to become a problem for water management, especially when we have this beautiful airspace here that's acting as a pressure drop in my system, which forces the water to fall due to gravity, right? And that space, 3/8, That's kind of a magic number in that a water droplet can't suspend itself across that space. So the water is forced to drop. It can't bridge that. If you did something a little shallower, water will migrate down, but it can also be held in there and suspended in those smaller spaces. But we want that to drop in gravity. So what are we doing now? I tape up that. I get rid of most of the holes, any penetrations that, I might have going through here, pipes, wires, all of that. I have to do a good job flashing at the surface of the weather-resistant barrier, or in this case, the zip, or what I'm calling the Alamo, right? But this drainage space, what it's really doing is getting rid of water, right? So if I get rid of the water and I seal up the holes, having the airspace gives me a pressure drop where I basically get rid of a bunch of the forces in action. There's still some capillarity and some things that can happen there. But if I get rid of the water and I get rid of the holes, then I really don't have a potential for any leaks, right? And so what have I done? I've created a water management system that puts my wall assembly in a position for success. So anyways, so that's what I call the Alamo. Get that weather resistive barrier in there in whatever case and material you want to use. In this case, it was that Zip R9 sheathing, but getting that airspace in front of it behind the siding is the most important part of that whole assembly. And it's for these reasons: getting rid of the water, getting rid of the holes, and getting rid of as much of the forces that will act upon that as possible. And if I can get rid of 1, 2, 3, then I get rid of leaks. And if I get rid of leaks, I have a successful water management problem. So there you have it. All right. So Big Red, going to bed. Hopefully you guys enjoyed that video. Anyways, again, water management, #1 killer of buildings. I can say that 1,000 times. And believe it or not, we'll still have some buildings to investigate next year and some problems to look at due to water management. It kills us. But anyways, if you're looking for more, feel free. You can follow me on Instagram at Steve Basic Architect. You can follow my daughter, who also works with me. She's Alexandra Basic on Instagram. And we're both posting stuff regularly. She does some writing for Green Building Advisor and posts a bunch of details. And she works really hard at it too. And we're all learning. So check it out. Even further, you can check out the Unbuild It podcast. We're on all the podcast outlets, Spotify, all those good, iTunes, etc. But we're also on YouTube. So go check it out, and you can see the antics behind the scenes, where I team up with my good friends Jake Bruton and Peter Yost, and we talk about this stuff. Water management is always one of the top things we talk about. So go check out those podcasts. Other than that, we have over a year's worth of videos on the Build Show Network. We're still putting stuff up there every week. Videos go up by me, my good friends Jake, Wade, Brent, and Matt. All great information for you to check out. So go check it out. Like the sign says, you got to watch the videos about 7 times before you really grasp the concepts inside there. So have at it. You watch them once, go back at it. Guaranteed you're going to learn a little something more 2nd, 3rd, 4th, 5th time around. So anyways, thanks for joining us this week. Until next time, long live our buildings.